Okay guys, so getting straight to the business, we are supposed to evaluate the integral from e to e squared of the log base x of e plus dx. Yes, so the dx is inside of the logarithm and then minus the reciprocal of the natural log of x without the x at the very end. Okay, so how are we supposed to do it? Well, as you can see, the dx, the natural x, is inside of the logarithm. It's inside of the function. We are not multiplying by it anywhere in the integral at all. Well, does this thing even make sense? Well, it sure doesn't, because if we are when we are trying to calculate the integral and definite integral of some function, this is the area under the curve on some kind of an interval that we calculate by dividing that interval into small regions that have the width of dx, this small change in x, and the height of the value of our function at that particular x value at some kind of an endpoint, or maybe at the starting point of that sub-interval. And so, well, then it makes sense, because then you just, make dx approach 0, you make smaller and smaller and smaller rectangles, so we get better and better and better approximation, because, well, it makes sense. It makes sense to multiply height times the width. Yeah, this is gonna be just the area, but what the hell is going to be height of width, or the natural log of width minus another height? Is how does this thing even make sense, for God's sake? Yeah, so, well, we don't care that it doesn't make any sense at all. We are here to break math, so we are going to calculate this guy anyways. Well, how are we supposed to do it? Well, nothing changes the fact that if we want to get this area under some kind of a curve, well, we still need the dx, we still need to get that slight notch, we still need to get that width to multiply our height by. So how do we do that? How do we get that thing? Well, what I would like to do here is kind of insert in my dx right here. I'm just gonna do it, yeah, okay. But if I'm multiplying something by something, I also have to divide by that thing for my value not to change. So what I'm gonna do is I'm actually gonna multiply and divide everything inside of that integral by my dx. Can I do it? No, but do I care? Also no, so I'm just gonna do it. Well, now we're writing my integral with this new kind of a fancy design. I'm gonna get the integral from e to e squared of, well, now it's gonna be my log base x of e plus my dx, and then minus my reciprocal of the ln of x, and everything divided by that dx, and then everything multiplied by that dx. Okay, so, well, now how can we kind of proceed further from this point? This is a mess. So how are we supposed to integrate it, especially that we have this dx here inside, and well, nobody probably knows whether we should integrate it with respect to x. We have to integrate with respect to x, but do we do anything special with dx? It's right there, so, well, what do we do with it? And I would like to kind of introduce a neat trick there. Well, you see, this dx right there is abysmally small. It's abysmal. It's infinitely small. Yeah, it's going to be approaching 0. So we can just kind of take the limit as this entire thing right there in the integral approaches 0, and just see what we're gonna get out of it. Yeah, so let's try and do it. We can just write this entire thing as the limit. So let's maybe replace the dx with some kind of an h. Yeah, so as some h approaches a 0 of the log base x of e plus that h, then minus the reciprocal of the natural log of x, and then everything divided by h. But now, well, what can we do further with that stuff? Well, do we know what this reciprocal of the natural log is? Well, by the base change formula for logarithms. We know that whenever we have a log base a of b, it's actually equal to the natural log of b divided by the natural log of a pretty nicely. I'm just gonna move it slightly so it doesn't mix up with all that stuff I was talking about. Now, I was drawing when talking about curves and areas underneath those. Yes, so you know that log base a of b is the natural log of b by ln of a. But well, here by this exact formula, by just kind of plugging in a equal to x, and b being equal to e, we get that by this thing, the 1 over the natural log of x actually equal to, well, log base x of e pretty nicely, because this is going to be equal to the natural log of e, which is 1 over ln of x, so exact thing that we started with there. Lovely. So well, let's rewrite this stuff as such using this formula. So we can write that this limit is going to be equal to the limit as h goes. Okay guys, so my camera died, but it's, you know, absolutely perfectly normal. So we are getting back to the problem. Well, we are given that it's going to be equal to the limit as h approaches 0 of log base x of e plus h minus log base x of e all over h. But the problem is that as h approaches 0, this log base x of e plus h is just going to be approaching the log base x of e. And so we are going to be given a log base x of e minus a log base x of e in the numerator and just an h in the denominator. Well guys, this is just an undefined 0 over 0 situation, so a perfect place to use the L'Hopital's rule. And so by the L'Hopital's rule, this limit is going to be equal to the same limit as h approaches 0, however with the derivative with respect to h taken over the numerator and the denominator. And so let's go on and apply the L'Hopital's rule. So this limit is gonna become the limit as h approaches 0 of log base x. It's kind of messy here, so I'm just gonna delete this d over dh maybe. Oh yeah. So the log base x of e plus h with respect to h, the derivative of it is gonna be just, well, that's just gonna be the log base x of e plus h, and then it's gonna be multiplied by the natural log of x, natural log of x, and then we'll minus the log base x of e. The derivative of this thing is just going to be 0 because log base x of e is just going to be a constant with respect to h, and so we are not even writing it down. And then the derivative with respect to h of h is just going to be a 1, and so this entire limit looks like this. Now plugging in h equal to 0 for that thing is just going to give us nicely the log base x of e multiplied by the natural log of x. But now we'll recall the formula I just talked about, the change of base formula for logarithms. This thing right there is equal to natural log of e all over the natural log of x multiplied by the natural log of x, but that's just, well, natural log of e, which is equal to a 1. So this entire limit from the very beginning was equal to 1. This entire integrand here in the original integral, after applying that d over dx over dx, multiplying by it, is just equal to a 1. And so we can rewrite our original integral. I mean, we probably can't, but I don't care about it. We can write it as the integral from e to e squared of just 1 dx. And well, this thing is simply just e squared is just e squared minus e, and don't forget the plus c, because, well, we're not engineers here. We do always write the plus c after doing a definite integral. Lovely. And so, well, e squared minus e is a result of this abomination we've got right there. So let's maybe go through what we did here in order to get this result that we just got once again. So what we did is, well, first of all, we noticed that this doesn't make any sense at all, you know, drawing all that stuff here in the coordinate system and just talking about what the hell integration even means. So we then I mean, as the problem we were trying to solve didn't make any sense in the first place, we thought that maybe we could make it, you know, don't make any more sense at all. I mean, no, we could make it make even less sense. And so we divided and then multiplied the entire integrand by a dx, which is something that approaches a 0 actually, and then just took care of what is the integrand, so the log base x of e plus dx minus the reciprocal of the natural log all over dx, and we just, well, thought to ourselves, bro, like dx is just approaching 0, so why not replace it with some kind of an h and just take the limit as h approaches 0 of that thing, bro? And with that bro science of ours, what we got is just that this entire limit after applying some L'Hopital's rule and stuff like this turned out to be equal to a 1, and then we just plug that 1 nicely into our integral inside, just replacing our integrand with that stuff, and then what we got is that that the integral between e and e squared of 1 dx is just equal to e squared minus e, and then I just laughed at, you know, all of those poor engineers with adding a plus c even though it's a definite integral, but I have no, absolutely no, I'm not going to erase it. Okay guys, so I really hope you enjoyed this video. If you didn't, like and subscribe to my channel not to miss out on any more fun stuff in the future. I'm actually posting every single day, so there is a lot of stuff to miss out on. And if you like this, then I'm happy you're happy and everyone's happy. See you in the next video. Bye.